So this is basically the layout of the software. The software is Vali Studio. And what I will show you here is another platform we implemented in the North Sea. It's the Amstel field. It's located in the North Sea, and it's managed by Neptune Energy. So the application is divided in different process flow diagrams. So those are the little boxes you can see here. Q13 is the production platform, while P15 is the separation platform. The model contains all the different pieces of equipment of the process. So you can see pumps, you can see heat exchangers, you can see chokes, separator vessels, and that kind of thing. And all those different pieces of equipment will be implemented with their corresponding equations. So you will have mass balance, mass and energy balance. You will have the head curve for the pumps. All those equations will be put inside the model as well. On each node of the model, you will have different tags, different measurements. So the tags will represent either a process measurement or a soft sensor. So if I take this example, this is the model of one of the wells. And if we look at the upstream point of the choke, you can see here at the bottom that we have three different tags. We have one pressure tag that is coming from the process. We have one temperature tag that is coming from the process as well. And we also have a soft sensor on the gas volume fraction at the inlet of the pump, which of course is important to follow if you want to avoid tripping of the pump. And in this case, you can see that based on those measurements and the thermodynamics of the model, you can see that the gas volume fraction at the inlet of the pump is 3%, so it's acceptable in that case. Now, if we go in the separation process, each well can either be directed to a test separator here, which is not a separator, it's a MPFM, a test MPFM test line here, or directly to the production. This vessel will separate the hydrocarbons from the water. The water is being rejected in the reservoir. And then going through this pipeline here, we can go to the separation process where we will separate the oil and the gas. At the end of those two processes, we have the fiscal meters. And what we actually have in this model is a reconciliation between the different virtual flow meters of the wells and the separated values here. So what I forgot to mention is that for each node of this model, we can put the different process measurements. For this case, I'm looking at the upstream of the pump here, and you can see two different measurements, the pressure and the temperature here, which are process measurements, but you also can see a soft sensor on the gas volume fraction. And this is a parameter you want to follow at the inlet of the pump because you want to avoid pump tripping. So because we have the thermodynamics and we know the composition, we know the temperature, the pressure, we can calculate this gas volume fraction in real time. And we can follow that specific KPI on a real-time basis as well. The last point I wanted to show is that, okay, we do a model of the process, but we also need to generate the data. And this is done through a specific workflow where every hour or every 15 minutes, if you want to, you will have an acquisition of data on the process data. This data will go through the reconciliation process, and then the corrected result will be stored on a specific database. And this is where you get your data to manage your process. So here I'm running the reconciliation. The reconciliation will be an iterative process, so you will have different iterations, and we're trying to solve all the different equations of the model at the same time, while we have a minimization function that's actually minimize the total penalty, the total corrections we have to put on the measurements, while satisfying all the different equations of the model. So this is what you can see here. This is the reconciliation process. And we have different values here in the analysis section, where you can see the number of tags of the model, which is more than 1,000, and especially the number of equations. So we are solving 1,600 equations at the same time here in this specific model. The last point is the number of redundancies, and this is really where the DVR will fetch the additional data it needs to correct all the measurements.
Yeah, 47 in this case.
Yeah, 47 in this case, yes.
And that's for the end-to-end, I guess, convergence that takes into consideration the wellbore information as well as all the way into the sales meter at the end.
Yeah, both platforms, yes.
So we have a bunch of questions here, so let's catch up on a few of them. I know Danielle was active on some of them, so we'll try to address as much as we can, but others are also coming in. So let's maybe address one of Danielle's questions about, or a couple of them. Danielle is asking, is DVR using a regularization strategy to avoid overfitting and finding maximum likelihood estimate of state of the system? Otherwise, is the penalty coming directly from the a priori uncertainties assigned to each data source process input?
Yeah.
Do you have a comment on that? Since
yeah. I mean, that's totally right, especially the second statement. I mean, the penalty is coming directly from this assumption that you know what the uncertainty of the initial measurement is. So in a sense, that's also the I would say a bit of a fragile part of DVR, especially when you look at upstream and you have, for instance, multi-phase meters that you use. Then, of course, you have the vendor spec, but you can also have meters that are performing in a region where they are not that comfortable. It also depends on if you look at oil flow or gas flow. So to estimate, so to get this a priori uncertainty, that's kind of a big challenge. And this is also one of the biggest challenges that we had for this Cherry Valley Hash project, that we had to estimate what the uncertainty was of all these 120 measurements, taking into account DP ranges, if they were calibrated, if the conditions are harsh for this meter. So there's a lot of uncertainty in the determination of the uncertainty already. So yeah, that's something that we need to deal with. It's either choosing between two worlds. Either you don't assume anything about the uncertainty, so you just disregard and take every measurement as equal, or you put some like prioritization of where to put your imbalance in that sense. So yeah, so it's indeed true. Yeah.
Thank you very much. Timothy, I know you handled these penalties with sensitivity analysis. Can you comment on that in the model?
Yeah, well, I'm not sure the sensitivity analysis run in that specific case, but we do have access. No, I didn't run it. We do usually have access when we see one specific tag that is reconciled outside of its range of expectation. We can see the link between all the different equations and the different. Let me just generate that. I will just rerun it while I explain.
You can do it.
Yeah, well. So we will see the link between the different variables. So when one is corrected, you can see which are the different variables that allowed to correct that specific measurement. And I have one in mind here, which is the speed of the pump in that specific case was reconciled outside of its range of expectation. It was a water pump. So I will look with you what are the parameters that allowed the correction. And from my model, you can see in red, I have a part here in my model that is reconciled outside its range of expectation. That's its specific pump speed here in the water injection train. And if I do the individual view in here.
While you're doing that, I mean, if I can probably comment on something else here. I see there are a couple of questions about DVR, and Jean-Paul was also mentioning something about VFM and DVR. But Danielle is mentioning that. If I can quickly comment on that before I address a question to Tom. Yes, DVR in particular, it's an approach to DVR really. I mean, DVR is not DVR, VFM. There are different methodologies to do VFM. Some of them are more sort of the ones that that are more deterministic, if you like. You have the equations and you try to kind of get between these different equations, the different answers, and then get the best out of all of them. DVR does that very nicely in a very elegant way because it incorporates all this data within the expectancy range of each of the sub-models that you have in there. And for that reason, when it comes up with the most likely flow rate out of that is because it has tried to reconcile the best out of the different measurement, whether it's the inflow performance or the vertical lift or the choke model or even the MPFM at the end, to the extent that when you link physical flow metering measurements with the virtual flow metering measurement together, you can actually within the VFM basically do some sort of self-tuning as you go by doing that. So I hope I sort of answered the question. We can take some of these discussions probably outside. I don't want to kind of spend much time on that. One thing that is about allocation that Tom probably you hinted to also allocation in your talk, and can you probably give more perspective about that? Is there wide acceptance of using DVR outputs as in allocation by operators? Using DVR outputs as in allocation?
Yeah, I think it's coming. You know, I think it's starting to happen. You know, we don't see part of the problem is that we've got measurement and allocation agreements. Certainly in our company, we've got measurement and allocation agreements with commercial partners, and those measurement and allocation agreements work within the context of a regulatory framework. And these documents have got a very long timeline, you know, and in these documents they basically say this is how you shall do it. So to bring in new methodologies takes a lot of time, you know. It's a kind of conservative industry.
Yeah.
And so but the thing that helps us here is when we've got papers like the paper from Dennis and the paper from others that actually start to show examples of where DVR is working and where it's helping us get like an equitable allocation of cost and revenue, and where it helps us actually guide investment decisions around where we should or should not invest in expensive technology is kind of what we do in our paper. I think as we start to move these things forward, then I think the acceptance will accelerate.
Thank you. Yeah, great. And like you hinted, Dennis has explored that quite in depth about the allocation and the different methodologies of allocation and how DVR potentially encompasses the different methodologies and can be reduced to one or others of these other methodologies depending on the particular situation. But I think the industry is learning about that, especially in upstream, and I feel on the long run that's going to gain more and more acceptance. We have now a number of publications on this topic. You mentioned, I think, Danielle, about whether this is related to being a principal component analysis, the PCA. I think it's a broad subject to talk about, but I invite you to go back, and that's well discussed in the VDI 2048. That's a standard on DVR. That's the German engineering standard of DVR, which Vali is compliant with. And I invite you to kind of look into that. That's a question that's quite deep but in principle, yes, it is pretty much related to principle of component analysis, if I may say so. But for more in-depth analysis or reading on that, I would invite you to go to VDI 2048, as mentioned. Not sure where we are on time. We have other comments from the speakers from the panel. Do you see anything that you would like to comment on the list of questions?
Can I comment on the virtual flow metering one, just to maybe just a simpler answer, you know? So virtual flow metering can be something extremely simple, like putting a differential pressure across a flow conditioner. Right now you've got like even further flow measurements, something really, really simple, right? An empirical based type of deal where you don't have like a standard discharge coefficient like you do in 5167 or something like that. It's just, you know, virtual kind of utilization of something that's there. Or you can have a complex virtual metering system, something that's subsea, use all your subsea infrastructure, you know, choke valves and CDs and pressures and temperatures, and maybe have a multi-phase flow meter there. You've got a network of stuff. These are all like basically just big calibrated flow conditioners, right? I mean, they're all just things that are there that are being utilized to give you some information, infer some information around flow. I think where DVR is different is DVR takes advantage of all these instruments as well, but it incorporates the uncertainty of each one. And I know you're having this discussion about a priori and all that, but it does take advantage of all of these But the key is it doesn't just take advantage of them; it takes advantage of them simultaneously, right? I think that's the key here. It's not like we just have an empirical input, some kind of function block calculation, whatever your calibration factor in inverted commas is, and an output. What's happening here is the whole system is connected as one entity, and then all of the uncertainties are bounced around with each other. And so the virtual flow metering system is kind of like just almost like the conventional forward calculation model that we talked about, HYSYS and so on, whereas the DVR's got this extra layer of uncertainty, plus everything gets solved simultaneously. So it's a much more elegant, sophisticated type solution.
Yeah, because often, and you brought a very good point here, is that often with VFM, you're doing things on a more sequential way where you have results, you have well tests, then you tune to well test, then you put this thing back in and kind of eventually verify these results, as opposed to have this whole process being solved simultaneously in a DVR environment. You're absolutely right. I think we're coming pretty close to that. I would like really to thank our attendees for taking the time to stay with us on this discussion. I think it's a very good discussion, very good questions. Sorry we could not get deep in every one of them, but feel free to reach to us at any time to have a more in-depth discussion about any of those. And with that, I would like also to thank very, very much again my panelists here who kindly agreed to be with us during this session. Dr. Dennis, thank you for joining us from the Netherlands. Tom as well, from taking the time with us, and Timothy from Belgium. Of course, it's getting a bit late for you as well. So our attendees, you're most than welcome, and it's time to maybe disconnect. Thanks again, and have a good day.